Hello and welcome to the next video in the series where I am now reassembling the engine that was removed from a Pangor Penguin amphibious ATV. This is a Villiers 9E engine equipped with a 4-speed transmission and reversible SEBA Dynastart. And we're going to start today by removing the right hand side cover, which is temporarily installed in the last video to set the points temporarily. We have to remove this cover for a couple of reasons. One is that the two screws that hold the cover on, here and here, the threads on the screws are damaged, and I believe the threads that the screws screw into are also damaged. So we're going to check those and repair them, hopefully. I've got the nut off the stud here. This is all that's holding this cover on, other than a little bit of friction where the cover fits over the dowels, the sleeves that hold it tightly in place here. There's the nut and washer. There we go. Just wiggle that cover off. The nut and washer back on it here. We do have a few things to do on this cover while we have it off. These wires for the points need to be run through the grommets that have to be installed yet, and I've got some sleeving to put on these wires as well. But for now, I'll just place this cover out of our way. And we're going to remove the clutch bridge. First thing I'm going to do is loosen the adjusting screw off of the clutch lever, because there's an adjustment I have to make on the push rod in behind here. So while we're at this side, I'm just going to go ahead and take the clutch bridge off. I'm first going to loosen the adjustment screw off. I had it tightened to get the cover installed, and that shouldn't be necessary. The cover should actually go on easily. The push rod here, I have either there's an issue with the adjustment or I've completely forgotten to adjust it, so I'm going to remove this clutch bridge. So we can see the push rod. Nut here and a screw here. Remove. I can't get a straight shot at the screw with the screwdriver, so I'm going to completely remove this adjuster. There's a little sprung finger here that goes in the notches on the adjuster to hold it in position once it's set. So we'll just remove that adjuster. And this lever should be loose like it is now, but it should be loose when that adjuster is in place. So remove the screw. Plan is to make this adjustment and reinstall at least the clutch bridge. We'll have to check the threads in these holes before we put this cover back on, and the cover needs that insulator, insulating sleeve, nut, washer, and the clutch bridge. We'll take that lever completely off, and we'll set everything here on our clean work surface, just off to the side. And this is the push rod we want to check the adjustment on. Now, whether it's correct or not, and I believe it is not correct, we're going to have to remove the cover off the other side of the engine, because we need to access the studs for the cylinder, which are right close to this cover, so it's going to be easier to put the cylinder on if we take this cover off. So I'll just turn this engine around. Make sure we're in frame here. So now I'm going to remove the two nuts that are loosely installed here on the fan. Two nuts, one to be jammed against the other. I've just got them installed loosely here. I'm still hoping to get the correct tool to hold the fan so I can torque these nuts properly. I may need to use the strap wrench on the rotor on the other side of the crankshaft to torque these two nuts, but right now I need the strap wrench to hold this rotor to loosen that nut. I'll be right back. So I'm just going to use the strap wrench on the rotor on the other side here. Make sure I've got it going the right way. And I don't. Turn it around here. This nut shouldn't be very tight. Strap wrench on the rotor. There we go. Was not very tight. Still need the ratchet to remove this nut. The nut is off. The nut is off our work surface and underneath our bench here. Rescued the nut from below. So now the fan should come off. There's still a lock washer here. To gently convince it from in behind here. Make sure our lock washer is not holding anything. Lock washer is off. So I'm just going to pry gently on that. You may notice this fan. Oh, sorry, take the strap wrench off here. You may notice this fan is missing a blade. That's a very common occurrence on the engines I've seen. When working on these engines, a lot of times you find that the engine is stuck, and it's very tempting to put a pair of pliers or a screwdriver down in between the blades of the fan in an attempt to roll the engine over, and this is usually the result. Now, I'm not sure what exactly happened to this fan. The fan does need to come off with the hub. These screws, although quite visible and quite tempting again to remove, the end of the screws is peened on the other side, so those screws are meant to be left in there for the duration. And we just about dropped the fan and possibly lost another blade. Now we want to take the side cover off. Our woodruff key is still in position, and this cover should come off without disturbing the woodruff key. The seal should come off well clear of that woodruff key. So I just need a socket to... Actually, I'm going to need a wrench for that nut. There isn't quite enough clearance for a socket. Let's see if I've got the right wrench here. Yes, I do. Okay, so just carefully remove this nut. Again, we're removing the outer half of the chain case, because part of the lower cowl here, the lower fan cowl, is very close to the studs and nuts for the cylinder, and this nut here in particular is going to be very difficult to tighten properly with this housing on. So remove this outer chain case. There's a gasket between the outer chain case and the inner chain case. And that nut should be all and washer should be all that holds this cover on. And there is a gasket there which should be firmly stuck to this part of the chain case. There it is, the gasket is on there. That's a new gasket, a recent gasket. That gasket will be reused. I'm just going to set it away. And I'm also going to put this fan out of the way. So now we see the adjuster and the lock nut for the adjuster on the pushrod adjuster. We'll move some more of these tools out of the way. And we'll turn this. Perhaps the camera can see what it is I'm doing here. Let's check out the view here. Come in a little closer. Adjust the camera just a wee bit. Okay, so what we're concerned with is this pushrod right here. The lever that we removed pivots on the adjuster that was removed and pushes this pushrod. And this pushrod, now you can't see because of how close I've got the camera, pushes against the adjuster and the nut on the clutch. So I'm just going to get the gauge I made. So I made a gauge which should be in up between the pages of my manual here. I see it, there it is. So according to our Villiers manual, there's the dimension for the clutch lever, and there is the dimension for the pushrod. The pushrod should protrude from the cover 5/16 of an inch. Now they're showing it with the clutch bridge installed, but I've removed it for access. So what I've done to make it a little easier, hopefully, my arm, is to make a gauge just using serial box. So the depth of this notch from here to here is 5/16 of an inch. Oh, sorry, knock the camera. Put the camera back. So that gauge touching the pushrod is not contacting the cover. So as I suspected, the pushrod is protruding too far. So I'm going to have to loosen the lock nut on the other side of the engine here, which you can't see. I'm going to need to use my strap wrench again on the clutch basket. I'm just going to hold the clutch basket. You can't see me doing this, but I'm just going to loosen the lock nut on the adjuster. Zoom back here. See if I can show you here. So here is the bag for our engine disappearing. The lock nut is here. The pushrod adjuster is here. So I've loosened this lock nut. So what I'll simply do, get the lock nut loose, is put a little pressure on the pushrod, turn the screw until I think it's about, the pushrod is about right, check it with the gauge, and continue adjusting until I have the pushrod set according to the gauge, and then I'll tighten the lock nut as I hold the screw. So I'll move the camera back here. Move the camera so you can see right where I'm working. Okay, so pushrod is out too far. Lock nut is loosened. So actually I'm just going to use the lever here to hold a little pressure on that push rod and turn the adjuster screw. That's a half turn. That's a turn. We'll see how that does. So with our gauge, actually it's a tissue box, not a cereal box. The end of the gauge touching the flat spot on the engine case here. There's a nice flat spot right there. The gauge touching looks like it just touches our screw. Actually, it's not quite touching our screw. There's a little bit of an error in my gauge. I've got this at a slight angle, so my gauge is not perfect. Push that push rod out just a little bit more. There, I believe that's where it should be. So I'll hold the push rod adjuster with the screwdriver and tighten the lock nut with the wrench. And of course now the clutch basket wants to turn. Turn the strap wrench around. Tighten the lock nut here. There, and the lock nut is tight. So I'm going to rotate this. Actually, I'm going to leave it at that angle, and we'll put the clutch bridge back on. The clutch bridge goes with the finger towards the front, and the spot for the screw is countersunk where the washer goes on flat, so it's relatively easy to remember which way that goes. So I'll just hang it on the stud, start the screw, put the lever in, and the lever has a blind hole in it, and it has a depression here. The blind hole goes, that's where the adjuster goes. So I'm going to put this the lever in place and put the adjuster in. Actually, I can't do that. That's going to be in the way of me tightening that screw. That's right. So we'll put the screw in here. There should be enough clearance between the push rod and the bridge to install that lever. Put that screw in snug, the washer on. Again, this is one of the original nuts that's flat on one side and chamfered on the other, so we'll put the chamfered side out. Even though it's a British standard Whitworth nut, a 9mm wrench fits it quite well. So tighten that nut, tighten this screw, and install the push rod, the push rod lever, Wiggle, wiggle. Install the adjuster. Now, there is a dimension given in the manual for this lever. As you can see, as I tighten the adjuster, the lever pivots on the push rod and comes outward. So let's just consult the manual here, if I can find that page. Look at that, fell to it. Actually, the distance it gives, if I'm in frame here, the distance it gives is between the lever and the cover. So, I'm going to install the side cover, just temporarily. Actually, now we can adjust this adjuster through the hole here in this cover. I'm just going to place this on temporarily. And I've put the nut and stud on so I don't lose track of them, and now they're in the way. Take them off. Set the cover on. I'm just going to hold it on just to see if I've got the... No, that lever is still hitting the cover. But now, if I loosen the adjuster, there we go. Now, previously, with the push rod out too far, this lever was touching the cover, and the only way I could get it to move away from the cover was to tighten the adjuster. Now I've loosened the adjuster, and there is play there, back and forth. I'm going to say approximately 1/8 of an inch, but there is play there, so there is clearance between the cover and the lever, so that's approximately correct. The 1/8 inch isn't absolutely critical. All we want to know for sure is that the lever is not held tight against the cover. That would mean the springs on the clutch aren't holding as much pressure as they could be against the clutch plates, and the clutch could possibly slip. So we have free play there, clearance. So that's... the push rod is now set to its proper length, and the lock nut is tight on the adjusting screw. So next, we can check the threads on the screws for this side cover and the holes that the side cover screws thread into. Now that I have the tools here, I got a 1/4 inch by 26 threads per inch British Standard fine tap, and a 1/4 inch by 26 threads per inch British Standard fine die. Now, I took a guess that those were the correct threads, and what I did to just verify that I was on the right track was I took the nut off the stud on the front of the cover here and just took the die and used the side of the die with the lettering stamped on it and threaded it by hand onto the stud. It went on relatively easy. I actually put a little penetrating oil on here just to make sure if it went on easily, if there was any burrs on the threads, it would clean them up. So that die has gone on that thread, indicating that I have the correct die. So the die and the tap should be correct for the screws, which are the same size that go through this cover. Now, I've actually gone ahead and taken this screw and run the die down its length. Not sure if you can see it. The other screw here. This screw, this portion of the two screws where they're overlapping, if you can maybe see the difference in thread pitch. The difference in thread pitch between this part of the screw and this part, and by thread pitch I mean how close the threads are together here and then how far apart they are here. This has been threaded into something, I don't know, maybe a standard 1/4 inch nut or something, but a screw with variable pitch threads on it like this, or varying pitch threads, is going to jam and do all kinds of nasty things to the two holes in the engine here. And I'm not sure what condition those holes are in, and actually now that I have this screw with repaired threads, I can just try it in these holes. It doesn't go in very far. The top one, now it is going in the bottom hole. So I've got my cover in my way here. So the bottom screw is threading in fine, or the screw is threading into the bottom hole fine. So that those threads, I believe, are fine. Actually, the screws thread going right through the hole, so that hole I don't believe needs to be repaired. So what I'm going to do here, I'm not going to use, now I'm not going to be using the exact correct tool, so please, no nasty comments. This is, I know I'm not using the correct tools, this is how I'm doing it. So that thread on that screw has had the dye run down it, so the threads are cleaned up. That's the top screw. The bottom screw has not yet had its threads cleaned up. So what I'm going to do is I'm going to grip the screw in a pair of locking pliers here tightly. I'm going to put a little bit of penetrating oil on the threads. I'm going to take the die, and the die is tapered so that it cuts a little bit on one side, and by the time what you're running it on or what you're threading with it has come through this side, this is down to the correct size. So you always want to start what you're threading on the side of the tap that has the threads on it. So I'm just going to start this by hand, and I'm going to try to start it straight. Put it on as far as I can by hand, and it's not straight. And I'm going to try to start it straight. Put it on as far as I can by hand, and it's not straight. There, I believe I am on there straight. Now, this is where I'm going to do this incorrectly. This die, there are many different types of dies for many different classes of fit. For example, you can make the thread slightly undersized on your screw if you happen to be thinking of putting a coating on this afterwards, so you need the threads to be undersized to make room for the coating. So this die is actually split. So if I grip it, and I'm going to be using locking pliers, I don't have a die stock, the proper tool to hold this die handy. I'm just going to grip the die so I don't grip it. If I grip it this way, I'll be closing up this gap and making the threads on the screw smaller than they should be. So I'm just going to carefully thread the screw into the die and turn it a couple of times and back it out to break the chips off. And I'm going to hold the screw and turn the die, back it off, and I'm just going to thread the die all the way onto the screw, or the screw all the way into the die as far as the threads go on the screw. And now see, the screw is turning very easy because I'm at the portion of the threads that are not damaged. I'll just go right to the end of the screw, the threaded part of the screw, take the die off of the screw, take it off carefully so I don't mess up the threads as I take it apart. Okay, so now I'm just going to walk over to where I have some compressed air and blow the chips off of this, because those will be very sharp metal chips. So now our die is clean and our threads are even from start to finish, and we just want to check those. You can do that easily. I'm just going to take the nut off of this stud, which is the same threads, put the nut on this screw, and it threads on there nice and easy. So that's the screws, the threads on the screws repaired. So now I'm going to do something else incorrectly. I'm going to use this die incorrectly, sorry, this tap incorrectly. I'm just going to put some oil on it, some penetrating oil. And again, there is a proper tool to hold the tap. It's a wrench. It goes on and clamps the squares on here, or it looks like a the chuck on a drill that clamps on here with a little T-handle for getting into tight spots. So again, I'm going to rely on my locking pliers. And we shouldn't have to turn this in all that far, I hope. I'll turn it gently. There's two things I want to be careful of. Well, one thing is, I'm not sure exactly how much clearance I have behind where I am here before I hit this other casing, so I don't want to try to turn this any further if it gets really hard to turn. And so far it's turning fairly easily. It does feel like it's cutting its way in there, so it does feel like it's cleaned up the threads. Now it's, if I take the pliers off there, I should be able to turn this out by hand. Almost. Yeah, it's coming out. Now I'll just take compressed air, and there are some chips on the top. So that I just cleaned the top, and now I'm just going to clean out the hole here. Any chips. So if we take our screws, we decided that the short screw was the top one. We thread that in. That just threads in nice and easily. Now, I have made some progress on the cover here. I've added an insulating sleeve. This is actually heat shrink sleeving, but I don't need to shrink it, and it doesn't need to be heat shrink sleeving. It also doesn't need to be clear. The original was black, but it's in there just to protect the wires from being the insulation from wearing through on the sharp edges of this hole. The other holes here where the wires are going to pass through, I'm going to put grommets in when I can find the correct ones. This is an odd shaped hole, a little tough to put a grommet in there, so we'll install this cover and put the screws in and snug them up just to make sure they're going to snug up, just to try out these holes. So I'll take this top screw out, the shorter one, nut and washer off the stud. Start the stud in the hole, make sure the cam comes through. The nut and washer back on. I'm just going to snug that nut to so it doesn't rattle off. The screws are two different lengths. Longer one goes on the bottom, shorter one at the top. And these screws should thread in easily, which they do. And that is tightening up. And that is tightening up. So there we have some nice, correct, good condition threads for those two screws. And that is using a 1/4 inch by 26 threads per inch British Standard fine tap, which I'm now going to put back in its case to protect its sharp cutting edges. And then the die, 26 threads per inch, 1/4 inch British Standard fine, back in its little keeper to protect it. So now we're waiting grommets and a cylinder and piston. Oh, and while we're talking about dies and cylinders and pistons, one of these cylinder studs, the 4 studs here that hold the cylinder to the crankcase, one of them got knocked after I took the cylinder off. I believe it was this one here. You can't see it in the camera probably, but what I did, and I didn't capture on film, was I do have the correct die for these threads as well. So I simply, before I put the cases together, I put some penetrating oil on the stud, the nut was off of it, and I just took the die in my hands, I didn't use locking pliers on it, and just threaded the die down onto the stud and threaded on and off, and it cleaned the threads up nicely. Now the nut turns nicely on there. So that thread that was damaged, and I made note of early in this video series, has been repaired. So for those of you who were wondering when I was going to actually do that, it has been done. Before we install our right hand side cover, we need to install some grommets in the holes where the neutral indicator wire, in this case, neutral indicator wire comes out there, and the wires for the points come out here, these two holes. These holes are, of course, not protected. They have sharp edges, so the wires could possibly wear because of vibration. They could shake and wear through because of the sharp edges, so that's why we put a grommet on. And this grommet is not the Wallace and grommet. This is a rubber device. Here's a large one. It's like a sleeve, rubber sleeve with flanges on it that goes through the hole, and the flange on each side hold the sleeve in place. Unfortunately, the universal set I got from my local auto parts store, something I just grabbed off the shelf, while they do fit the hole, this is the hole for the neutral indicator wire, the material that it's going through, the case, is thicker than the spacing of the two flanges, so the grommet doesn't fit properly. It should look circular, which it actually doesn't even look perfectly circular on the outside. It should look perfectly circular on the inside, and it doesn't, so I'm going to have to see if I can find a grommet to go through a thicker material. So that's an attempt at installing a grommet, and again, actually this grommet, sorry, but these grommets aren't going to work. They would sort of work, but they might pop out, and then that would defeat the whole purpose of putting them in the first place. So I want to see if we can get some grommets that will fit here properly. And while we're on the cover here and installing things to protect us from sharp edges, here is some insulating tubing. It is 3/16, and I don't think it's shrink tubing. So let me get the label off of it here. It doesn't need to be shrink tubing. It is actually shrink tubing. It doesn't need to be shrink tubing, but we just need it to go through this hole. This is an odd shaped hole, so a grommet wouldn't work here, so we're just going to use a length of this sleeving. I'm just going to cut it off about here. I'm not going to bother running it through the hole here. The wires aren't really held tight against this hole, so I'm not concerned they're going to wear through here. So I'm just going to cut that about there and actually leave that in, and we'll thread the wires through it. Though these wires are for the points, they'll have to go up through the grommets when the grommets are installed, and then I will put bullet connectors on them. Back again already, because I think I found in my collection of spare parts some grommets that will work for the two holes for the points wires and the hole for the neutral indicator wire. So, for the last time I hope, I'm going to pull this side cover back off. Nut at the front, washer. And we'll use the impact driver just as a hand screwdriver this time. Bottom screw, which is longer, shorter top screw. those screws aside, whether or not in the washer, and the cover should wiggle off. It does. So what we're looking at here are the two holes, the two holes here where the wires for the points come through, and a hole over here where the neutral indicator wire comes through. Now, I'm in a bad spot here. Not got much room to work, so I'm just going to move stuff around here, and I'll be right back. I think I've moved stuff out of the way, so we've got room to work in, he said as he continued to move stuff out of the way. First thing I'm going to do is take the neutral indicator wire, this little yellow wire. On some machines it may be longer, but that's the way it is on this machine, and go into my grommet collection here. There should be two different sizes of grommets in here. The holes we're working on are two different sizes. There's a slightly larger hole grommet for the slightly larger hole. The rest in here. Put them aside. So the grommets I have are that size and this size. I measured the holes, and I believe this hole was 3/16 in diameter, where these were an 1/8 of an inch in diameter. So I actually checked the internet to see if I could find grommets in those sizes to fit a 1/8, I think, thickness of panel. Most grommets, it seems, are made to fit sheet steel, which is a lot thinner than our aluminum case. So I was having a difficult time finding grommets to fit holes this small in material this thick. Now this here, this isn't the actual thickness of the case. There's a heavier lip here where it sits against the other cases on the engine. I was going to say gasket surface, but there's no gasket goes there. So the actual thickness where the hole is slightly less than this. But my point, I guess, is I had a hard time finding a source for the proper grommets. I checked the place where I get most of my Villiers parts from, and they do sell a grommet which looks, by the picture, to be the proper grommet. It's one part number or one grommet, and it is listed as for low tension wiring, which these points wires are, as opposed to high tension wires, which is like your spark plug wire. So I was about to place an order from them and maybe order some other stuff from them, so I wasn't just ordering some inexpensive grommets, just to have some to test them to see if they did fit, and hopefully have some that did fit and use them. But I found these instead, so I'm going to try them. I'm pretty sure they fit. I actually test fit one in another cover, and it seemed to work. So I'm going to take the larger grommet, and our neutral indicator wire still has the bullet connector on it, and I'm going to leave that bullet connector on it because it's more of a challenge to fit the grommet through that hole with the wire in the center of it. So I'm just going to push the bullet connector through the grommet, and when I say just push, I mean with a little bit of force. But there the grommet is on the wire. Now when we put this wire in the case, we have to put it the right way around. Now actually, even if we mess up with this wire, we can correct it, because this end of the wire has the male bullet connector on it. This end of the wire has the sleeve on it, which would accept a male bullet connector. But if I really worked it, there's a male bullet connector in this end of the sleeve. So if I ended up with the wrong end of the wire inside the case, I could probably fix it, but I'm going to try to do it right the first time and see what happens. So we want the bullet connector inside the case, so we want it that way. So I'm going to lower the camera here, and what I've got here, you might not be able to see me do this, I have a smaller, not very sharp screwdriver and a even smaller jeweler screwdriver. So what I'm going to attempt to do, and I've done this without the wire, it's not that difficult, it's a little fiddly, but I'm going to try to push the grommet partway into the case with my bare hands, and then carefully use the screwdriver to stuff the flange of the grommet into the hole. So while putting pressure on the grommet to encourage the other flange to not pop back out, and trying not to poke myself with the screwdriver or cut the grommet with the screwdriver, and trying not to scratch the cover all to pieces. I'm just going to take a smaller bladed screwdriver and see if this will work some more. Of course, with the wire out of the hole, out of the grommet would go in easier, but then I don't think the bullet connector would go through, and I could unsolder the bullet connector, but hey, this is more of a challenge. So, well, like a challenge, right? See there, grommet has not gone in at all. Another way to do this would be to cut the grommet so we can start one end and then go around, but I'm going to give this a little more of a try before I completely give up and try a different method. This is a test of patience. I have no doubt it will go if I stay at it long enough, but how long do I want to work at it? That's the thing. When there are options, I can cut the grommet and it might go in easier, or I can just unsolder the bullet connector from the wire and install the grommet, put the wire in and resolder the bullet connector. Since that's what I'm going to have to do with the points wires, the bullet connectors are not on those wires. They came without. The points came without bullet connectors because you can't install them in the cover with the bullet connector on them. So I continue to work this. Of course, every time I ease up on it, it squirms back out. So now, we could also forego the grommet on this wire. If this wire wears through the insulation and shorts to ground, it merely means that your neutral indicator light's going to stay on when it shouldn't. Whereas the points wires, well, if they short out at the wrong time, the engine's going to quit. Well, I think I'm making progress here. Ooh, so close. That last little bit of the grommet wants to squirm out. My goodness, I think I have there. Excuse me. Oh, there. managed to push the cover out so that whatever I was doing, you couldn't see what I was doing. So the grommet is set in, but you see how the flange inside, the flange of the grommet, is not circular, so it's not all the way inside. So I'm just going to pick at it carefully with the small blade on the screwdriver here. Just try to pull it the rest of the way through there, just pop through there. And there, so there's the grommet installed. The flange on the inside is completely inside. Flange on the outside is round, so there, that grommet is installed. Next we'll do the easy ones. I've pulled the wires out. They don't have the bullet connectors on, so we can put the grommets in and then put the bullet connectors on. So I'm going to go back to my slightly less sharp screwdriver. Now these holes again are a little smaller in diameter. And unfortunately, I can't tell you exactly where I got these grommets because I don't remember. They might have been in an assortment I got from an auto parts store, just actually a hardware slash auto parts store. Some of them carry a selection of odd bits and pieces like grommets and window winders and fittings and stuff that they carry an assortment instead of carrying a specific size for your particular need. So you hope that in the $4 assortment there are 2 pieces you can use, and that looks like it may have been the case in this piece without the wire in it. This grommet is still being a challenge, shall we say. Going back to my smaller blade screwdriver. We want to tuck the flange of the grommet in the hole and hold a little pressure on it with our finger so it doesn't pop back out. And you can see there's a little bit of the flange sticking out here. Get that in the hole again. Try not to poke the screwdriver through it. Looks like it's going. It's going. Put a little bit of pressure on it here. Get the flange through. Now you can't really see the inner flange here because of where the hole is. The flange is here, but I'm just going to pick at it with the screwdriver to work it through, because of course if the flange isn't all the way through the hole, it could theoretically work its way back out. And if it does that after the wire's in, I would use some very interesting expressions to express my delight without having to fix them again. But anyway, the grommet, I'm not sure if you can see it, is coming through, and the wire should fit through. And now, speaking of wires, I checked on the other engine, the one that I don't think has been apart, and I don't know that it matters or not, but the black wire goes to the back. So black is back as far as that wire goes, and the front is this way, so the red wire would go through the grommet I just put in. And since we've put one grommet in, what the heck, we'll see if we can put the other grommet in. So I'm going to try to start the flange in the hole and work it in with the screwdriver. Now, I'm not sure if I mentioned putting some lubricant on the grommet. It might help. It might also make it so slippery to hang on to that you'd be going all over the place trying to catch the grommet. So anyway, we'll continue on with this grommet, pushing the flange in to the hole. Now, these I think are slightly undersized in that they may be for a thinner material. That's why I'm having that's why I'm taking so long to get them installed, because they're not meant for this thickness of material. So a correct grommet, one that's made for this thickness of material, may go through better. And actually, yeah, I've torn that grommet. See that? I've torn that grommet. I think I put the screwdriver through it. So we'll go back to our little bag of grommets and grab another one. I think there's only one size left in here. Looks like, yes. I'll try the less sharp screwdriver again. That was my mistake. Hoping you can see what I'm doing here, although it's hard to show. I'm simply trying to tuck the one flange in. I start the grommet on an angle in the hole and then try to tuck the rest of the flange of the grommet, the lip, into the hole. I don't know what else to compare this to. To be honest with you, even sometimes here, I can't see what I'm doing. Just going by feel here. I was going to actually test fit the wire in that other grommet before I started this one, but then I'd have to pull the wire back out because it would make putting this grommet in a little more difficult. And as you can see, I don't need any added difficulty. Just somewhere there's a tool made for this. It does it in a fraction of a second. Wow, this is being difficult. Go back to my smaller but sharper blade here. Try to be a little more careful with it. You know, I didn't actually expect this to take this long.
I would say if you're going to attempt this, make sure you buy a few spare grommets, because as you can see, you may spoil a few. Ooh, I think I'm winning. There. Okay, so the grommet is almost in. I'll pull it way at the inside here. I could actually do that with my fingernail if my fingers were smaller. Just work carefully at the grommet here. Try giving it a push with the less sharp screwdriver here from the top. There, I think that helps. There, that appears to be in. Okay, so there are our two grommets. As I said, the black one was the back one. I may need to get a pair of pliers for this. Get the wire through. Yes, I'm going to have to get pliers. I'll be right back. Pliers have been located, so we'll feed this wire through our new grommet. Hopefully not pushing the grommet out in the process. Now it's starting. The uninsulated part of this wire is coming through. And the insulation is there and could push the grommet out if I'm too pull too hard. I don't want that grommet pulled out after, like that, after all that trouble putting it in. Well, I'm going to go ahead and put the other wire in the grommet here, just to make sure it will fit. The red wire in the forward grommet. Work it slowly through the grommet. There we go. There we have one wire and one grommet. Oh, so that's... Oh, I poked through that grommet too. So I'm going to go and install this grommet off camera, and then when I come back, the grommet will be installed and the wire will be through it, and I will be happy. Anyway, it's a little bit frustrating doing this, but it's rewarding when it's done. So I'll just put this third one in, or actually this is the third one for the second time. I'll put this one in off camera and come back. There we go. Red wire through a grommet that's not cut by a screwdriver. Black wire through a grommet not cut by a screwdriver. I went with the side cover and my two screwdrivers and a grommet, of course, and sat on a chair, placed the cover upright like so between my thighs, and with it upright so that I could see what I was doing and push downwards on it instead of sidewards and at awkward angles like I was doing in the camera. It actually went in not bad. And the wire pulled through without me pulling the grommet out. And this again is how it looks inside. I have placed a clear piece of heat shrink tubing over the wires, and again that's to protect the wires from the sharp edges of the cover here. if these wires were to wear through that, of course, that would mean the engine would stop. It would not run because it would have no spark. It would be like the points were closed all the time. So this doesn't need to be heat shrink. Originally it was just a piece of sleeving, but I couldn't find a chunk of the right sleeving in the short time frame I was allowing to do this, so the heat shrink is in and it's going to work. If it happens to shrink, it won't hurt anything. And our neutral indicator wire is in the right way with the bullet connector inside the cover, so it can go in where you can't quite see in the camera. But I'm going to change the camera angle and we'll come back and we'll put some grease on our cam and we'll install this cover for what I hope is the last time until this engine has been run. With everything repositioned, I think I'm ready to put this cover back on again. So what I have in the pill bottle is some Points lube, some Points cam lube. This was decanted from a larger tube, a lifetime supply of Points cam lube. It actually is sold as Ignition Points cam lubricant. I forget the name brand, but I'm going to use a little more than what'll fit on my screwdriver here. I'm just going to smear a little bit on the cam here. Maybe we'll take a little more. Hope not that much. Most of this is going to end up on the rubbing block of the Points. Just put a thin film on here. Okay, so that has lube on the cam all the way around. So as we put this cover on, we have to put the neutral indicator light wire, the yellow wire, we have to plug it in there. So we can put the cover near in position. Now this wire has a bend in it, I think where it came out of the cover originally. So we'd like, if at all possible, to have the same amount of wire come out of the cover. So I'm just going to use a pair of pliers to put that back in. Back in there. Oh, it doesn't want to go. Actually, it doesn't want to stay. So we'll just grip the wire with our pliers. Wow. This is being contrary. So bullet connector in the contact for the neutral indicator. We have the new pin in our neutral indicator pinion, so we'll slide this cover sort of into place as we pull some of that slack wire out. Start the stud at the front. Cam should come through. So there is the cover set in place. Put the nut on with the flat side towards the washer, just because. And the two screws, the ones we touched up the threads on, the longer one goes in the hole towards the bottom. Top one, therefore, is by default shorter. We'll take our impact tool and just use it by hand, because the bit in it fits these screws very nicely. Best chance of slipping. And we don't need to go McGill Gorilla on these. Just tighten them. And then this nut on the front. Again, it's British Standard Whitworth or British Cycle Thread or whatever standard it is. I think it's 5/16 fine. The but the nut anyway fits a 9mm wrench. So that nut is tight. These screws are tight. Our neutral indicator wire is out where we can get at it. We have lube on the cam. At some point I will put the bullet connectors that we saved. Actually, we saved one off of this cover, and I got one that I had from somewhere else. I'll put that on. Hey, what the heck. I'll reposition the camera, and we'll do that while I'm here. Then that's done. There are our bullet connectors that we're going to reuse. Now, they both happen to be on the same color wires, but that doesn't matter. I'm just going to heat them with the soldering iron. The wire protrudes from the center of the bullet connector, so I'm going to heat it with the soldering iron, soften this solder, and pull the old wire out. And then I'm going to put them on these shiny new wires with some new solder. Not sure if you're going to be able to see anything I do here. The soldering iron is warming up. I have some needle nose pliers, because of course one thing we're going to have to do to melt the solder, we're going to have to get this hot. And there isn't a whole lot of territory here. It's like when this is hot, this is going to be hot. So I'm going to have to hold it with pliers, or I'm going to burn my fingers. So this one bullet connector, this one here, should actually be cleaned a little bit. It's a little grungy. I'll do that one second. Just waiting for the soldering iron to warm up here. Okay, the soldering iron seems to be melting solder now. So we'll see. And my apologies to anybody who works in the high-tech department that actually uses a soldering iron and knows how. So, once again, my apologies to anybody that works in the high-tech industry and knows how to solder. So I'm just going to heat this, and then I'm going to try to push it off of the end of the wire, and this would be a good time for me to have a third hand, or a tool that mimics having a third hand. And you know what, I do have one of those. No, the bolt connector has just slid up the wire, so there we go, it pulled off. So the bullet connector is full of solder. So what I'm going to do, or attempt to do, no, what I'm going to do, there is no attempt, there is only do. Try not to hold it by the very end I'm trying to heat. I'm going to heat it to soften the solder, and then I'm actually going to tap on this cover carefully. I just want to knock the molten solder out. So that we can put the hot bullet connector onto the linoleum floor, cushion floor, sorry. Linoleum is, using the word linoleum is probably aging me, showing my age. Heat this up. I'm bound and determined I'm going to drop it again. Or it's bound and determined I'm going to drop it again. A little more solder on my soldering iron to help transfer the heat. Drop the bullet connector again. There, heat it some more. Drop it again. I'm trying not to pick it up right near where I'm heating it, because the pliers will soak up all the heat and it'll take forever to melt the solder. But if I keep dropping it, it's going to take forever to heat it up too. A little more solder. There, solder came out. I can see through the center of the bullet connector. So I dropped it again. Now, the wires here have solder on them. They're tinned, as they say. So I'm going to take this, and this one has been squashed a bit, so it's not round. This one looks like it's still round, so I think maybe that'll fit. Wow, that really likes the floor. Now, I guess what I'll do here is I'll try heating this wire. And see if the bullet connector, nope. Well, there it's kind of stuck on, but it's not on there far enough. So I'm going to hold the bullet connector. Put a little pressure against the wire and heat the connector. Hoping to melt the solder in the connector and the wire will, there we go, the wire has protruded out. So now I'm going to take some solder, a little more on the tip of my iron, heat the bullet connector and apply a little more solder to the end of the bullet connector. And it should soak in, wick in, and I think if I don't touch that while it cools, we'll have a soldered bullet connector. Now, solder that was on here that I knocked out, it solidifies pretty much on contact and it doesn't stick. So while I'm here, see if I can maybe change the shape of this wire. Oh, now it's trying to splay, so instead of making it smaller to fit in the connector, the terminal, the bullet terminal, the bullet connector, it's actually growing. There. So I'll try taking the wire out of this other connector and maybe clean it up when I get it out. Apply the soldering iron to heat there, and it looks, I can see the bullet connector spinning there, so maybe it will come off. No. And this is a place to have three hands. Okay, so I actually have a third set of hands, see? Someone else is holding the pliers that are holding the wire that the old bullet connector is on. And I put a little more solder on my soldering iron. So maybe, oh, it's trying. It wants to come out. Pull. Try a little more solder on our soldering iron again. Soldering iron, solder on the iron helps transfer the heat to the part we're trying to melt the solder on. And there, well, we have a couple of strands of wire in there, so if you could put that down, please, and maybe pull those two strands of old copper out of there, just let that go. And just, there's two strands of wire there. You can just see if they'll come out. No, they might just hold it there. Hold it there. We'll put some more solder on our iron here. Try not to burn ourselves. Well, our assistant lightly pulls on the wire that's still stuck in their connector here. Did that get one or two? That got one. I'll have to re-grip this. You see the other one there? Mm-hmm. So I'll heat this. There, it's moving. Oh, there, the wire's out, the bullet connector escaped. So I'm going to clean that bullet connector up. And I'll come back and solder it onto this new wire. Here's our cleaned up bullet connector. I took the pliers I had and just put it in the center. Polished as much as I could, then of course turned it 180 degrees and polished the rest of it. And I used the motor tool with the wire brush that I used for cleaning up the points to do this. And this one cleaned up so nice, I went back and cleaned this one up too. So they're nice and shiny. And these connectors, these bullet connectors or bullet terminals, are still available new. I did find a source for them. They are, I believe, 4.7 millimeter bullet connectors. You can buy the bullets and the sleeves, so you can install the correct terminals if yours are missing some, or they've got the incorrect ones and you want to put the correct ones on it. So now I'm just waiting for my soldering iron to heat back up again. I had to unplug it to plug the motor tool in. And then we should be able to install this bullet connector on this wire. Now the solder came out of this connector. You might be able to see through, but I could see through it, so you can believe me when I say the solder is gone. So I'm going to hold pressure against this wire again, or this wire, so that the soldering iron will heat the bullet connector and any solder in it and the solder on the wire, and hopefully the wire will then see fit to make an appearance at the end of the bullet connector. There we go. I see the wire wiggling in. And again, with soldering iron we're heating stuff up, so we're heating the insulation on the wire up too, and we don't want to overheat this wire and melt the insulation. I'm just going to let that cool. There, it did not stay. And it's rolled in away underneath the engine. I don't want to reach in with my fingers because it's hot. Soldering iron and stand. One pair of pliers to hold the wire connector. So grab it correctly with the other. We'll try that again. Not sure if the solder had not cooled when I moved the connector, so there, I'm going to remove the heat and try not to move this. If you move a solder joint while it's cooling, you get what's called a cold joint, and the solder is not strong at all. So that is on, but I don't think it has enough solder inside the connector, so again, solder on the soldering iron. Once again, apologies to anybody who works in the high-tech area and knows how to solder. Now that the wire is sticking out of the bolt connector just a little bit, and that's fine. There's lots of room inside the sleeve where it goes, so if there's a little bit, like a 1/16 or 32 of an inch of wire sticking out, I don't think that's an issue. So that has cooled without me touching it, so I'll just do a test here. Just pull gently on the bullet connector, make sure it won't pull off. There. Our bullet connectors are reused. One we reused that was on this engine, one we reused that was on another engine, but they're both original bullet connectors, and those will continue to serve. So, with our wires terminated, our neutral indicator light installed, I think that's as far as we can go on this engine until we have a piston and cylinder. Since there are no timing marks on this engine, ignition timing marks, we cannot set the timing until we have the piston and cylinder installed. We need to use a dial indicator to determine where top dead center is for the piston, and then we need to measure down, I believe it's 11/32 of an inch according to the maintenance manual, and that's where we need to have our ignition points open. The ignition points should open for forward when the piston is 11/64 of an inch. I hope I said the same dimension twice there, but I'll check the manual before I said it. The piston will not be at top dead center when the points open. That gives the spark time to occur and the flame and explosion time to start in the combustion chamber. So as the piston goes slightly past top dead center, it gets a push downward from the explosion happening in the cylinder. And to recap, the reason we don't have a piston and cylinder is the cylinder was damaged, it was scored, the piston was damaged, it was scuffed, and actually it had a piece broken out of it. So the cylinder is being machined to fit an oversized piston. So there at the machine shop, I'm hoping to hear word very soon that those two items are ready to come back. The piston went with the cylinder, so the machinist could machine the cylinder using the piston plus the clearance given that should be in between the piston and the cylinder as a dimension to bore the cylinder. So unless I think of something else that should be done, we are on standby waiting for our machinist. So in that case, I will conclude this video, this part of this series, until we get that word.